Hello guys, this is the second tutorial for the NeutrinoParticles editor, and in this tutorial I will continue to tell about basic and fundamental things of the editor. So here we see the effect from the previous tutorial. In this effect each particle has only one particle's property, lifetime, and it is enough to make particles move along the path. Let's make next thing. Let's create each particle in a random position on the path, keep it alive a couple of seconds, and then kill the particle. To make that, we will need to store in each particle the position on the path, because this position becomes another unique property of each particle. To store the value inside the particle, we will use block custom property. There are three blocks, custom property blocks, custom property, property 2 and property 3. Each of them stores different values, different type of values. First stores one component value, just a floating point number. Second, two-dimensional vector, and third, three-dimensional vector. The question is what we want to store inside the particle. Which value, which kind of value. As we remember from the previous tutorial, block path 2 takes value from 0 to 1, which is mapped to the path described by this block. So we can store a random value from 0 to 1 in each particle and then convert this value with path 2 block to the position on the path. Or we can store final position of the particle, like a three-dimensional vector in the space. So both of these variants are pretty similar. They finally looks the same. So let's make the first one and we will see what we will get. We add custom property to the particle. Let's name it something like path position. It doesn't matter what name has custom property, it's only for you, only for label on the block. We need to initialize this custom property when particle is created with the random value. To make that, random block used. We need to move init value of the property to the connector and send random value to initialize the property when each particle is created. So each particle will have its own random value from 0 to 1. And then we need to pass this random value to the path 2 block. Then this value will be converted to the three-dimensional vector and passed to the constructor. So let's make path more obvious. Here is it. We have particles creating on the path. Let's make them live shorter, 2 seconds, and here is it. Each particle has a custom property which stores, which holds random value from 0 to 1. This value is passed on each frame when a particle is prepared to render. This value, unique value for each particle, passed to the path2 block. This block will convert this value to two-dimensional position on the path. Then this two-dimensional position will be converted to three-dimensional position by adding 0 to z component, and then particle will be drawn. The second variant of the same effect is to store three-dimensional value, three-dimensional position of particle in the space. To make that, we will add custom property 3, name it the same, take out value to initialize to the connector, and initialize this property with position, three-dimensional position on the path. And then we pass this three-dimensional position to the constructor to render on each frame. Both of the, as I already said, both of these variants of the effect is the same, looks the same, but the second variant is takes much less computations because position on the path for each particle computed is only once when particle created. Then it is stored inside the particle, and on each frame for each particle this value is used to render the particle. Okay, now let's make particles to appear and disappear smoothly. So we will need to control particles transparency or alpha along its lifetime. To make that, we will use block curves. There are 3 blocks curves in the blocks palette. It is 1, curves 2 and curves 3. Each of them returns or gives on its output different type of value, 1, 2 and 3-dimensional vector. Since we will change transparency or simple floating point value, we will use curves 1 block. Transparency of the particle is specified inside constructor block. It's called alpha. By default it is 1. If we change it to 0.5, we will get semi-transparent particles. But we need to control the alpha while particle lives. So we will take take out or move alpha value to the connector on the constructor, and then connect curves block to the alpha. How does this connection work? As we remember from previous tutorial, from this expression block returns or outputs a value from 0 to 1, which is linearly changed while particle leaves. So on input of block curves 1, we will have this value from 0 to 1 when particle is created and just created. The value on this input will be 0, and in the end of the particle's life it will be 1. If you select the block, we will see graph which is stored inside the block. We can change this graph. You can add new keys by holding Shift button on your keyboard and click on the segment where you want to create the key. How does this block work? Input of this block is mapped to x-axis, and on output of this block we will have the value of the graph at that x position. So for example, if we will have 0.5 on input, we will get 0.4 on output. The result we can see right now in preview window. When particle is created, it is fully transparent, and then it slowly appears, then just slowly disappears, and finally when particle dies, it is opaque, or it is not transparent. So to make particles appear and disappear smoothly, we need to change our graph in this way. So when it is created, it is 0, alpha is 0, then it grows up to 1, stays 1 while particle leaves, and then in the end goes down to the 0 value. So the result is in preview window as we wanted. Okay, next step will be to control rotation of each particle. Let's make a random rotation for each particle. Now let's make background and texture of the particle more obvious to rotate. So we will change first the texture to something like this fish, and change background to white. This background is used only in this preview window. It's only for convenience, only for preview. And also let's change size of the particle to be not square but rectangle, which is wider, which is not square. Let's make it 60 width. Okay. Here we have our fishes. To make random rotation for each particle, we will need to store another property in each particle, another value. This value will be angle of rotation of the particle. So we add another property to the particle, which stores only one-dimensional value, one-dimensional vector, and initialize it with random rotation from 0 to 360 degrees. Then take out, then move rotation angle to the connector and connect our property, our rotation for each particle to that connector. And we have random rotated fishes. As you can see, I didn't give the name to the particle, but it's better to name them more obvious to remember next time when you open the effect. So I'll name it rotation or angle. Okay, let's do rotation. Okay. Now let's add color to our particles. Suppose we have a task to paint our particles in 3 different colors randomly: red, green, and blue. Okay, let's change back the texture to the star, because black fish won't multiply on any color. So where is our star? Here we go. And return back black background. And turn back our square particles. Okay. Now each particle should have the color, also the color with other properties. So color is represented as 3-dimensional vector in the editor. So we add property 3, and name it color. Move color to the connector. By default it is white 1, 1, 1 for each R, G and B component, and connect our color of each particle with this color. For now it is 0, so all particles are black. You can see here. So we need to let's change it to white, and now we need to color them randomly. To do that, I will use curves 3 block. I will initialize color property of the of all particles with random color from these graphs. How does it work? Each graph in this block, in curves 3 block, represents each component of the color: red, green, and blue. On input of curves block, we give random value from 0 to 1. So this value will be mapped to x-axis, and output will be the value of the graphs in that x coordinate. So for 0 on input, we will have green 0.8, blue 0.3, and red 0 component. And when we will have 1 on the curve 3 input, we will have 1, 0, and 0.7 on output. So when each particle is created, a random value is given to curve 3 block, and result in random color from these graphs will be stored in the particle property color, and then this color will be used when particle is drawn. So now we need to change these graphs to make them represent only 3 colors: red, green, and blue only, without linear change from color to color. So I will change our graphs in this way. I will use broken keys. These broken keys allow to change instantly value of the graph in the point. I will make red color to store in the particle when random value will give value from 0 to 0.3, green value from 0.3 to 0.7, and blue color from 0.7 to 1. So we will have a little more green particles than red and blue, but it doesn't matter for now. We have, as we expected, only 3 different 3 kinds of colors: red, green, and blue. Okay, this is the end of this tutorial. In this tutorial we figured out how to use graphs and curves blocks, how to use random block. We remembered how to use path2 block, and how to store values in the particle. So thank you for your attention. See you next time.